unveiling the secrets of the sun's core. Ever wondered what's really inside the sun? Is it solid, liquid, or something beyond human comprehension? Today we reveal the shocking truth. Welcome to an incredible journey into the heart of our solar system's most powerful entity, the sun. Have you ever wondered what mysteries lie hidden deep within the sun's core? Today, we will take a deep dive into the sun's core, uncovering secrets that have puzzled scientists for centuries. From nuclear fusion to extreme temperatures and the vital role it plays in sustaining life on Earth, we will explore the inner workings of the sun and reveal the astonishing forces at play. What is the sun's core? The sun's core is the powerhouse of our solar system. It is the innermost part of the sun, where temperatures soar to an unimaginable 15 million degrees Celsius, 27 million degrees Fahrenheit. This intense heat and pressure create the perfect conditions for nuclear fusion, the process that fuels our sun and provides the energy that sustains life on Earth. To put this into perspective, the sun's core is about 10 times denser than gold and produces the equivalent of 100 billion nuclear bombs per second in energy output. But how does this all happen? What makes the sun's core so special? Let's find out. The process of nuclear fusion at the heart of the sun's core, an incredible process called nuclear fusion occurs. This is where hydrogen atoms collide with each other under immense pressure, fusing to form helium. This reaction releases an enormous amount of energy in the form of light and heat, which then travels outward, eventually reaching Earth. The most dominant reaction in the sun's core is the proton-proton chain reaction. Two hydrogen nuclei, protons, collide and fuse, creating deuterium and releasing a positron and a neutrino. Another proton collides with deuterium, forming helium-3 and releasing gamma radiation. Two helium-3 nuclei collide, forming helium-4 and releasing two protons, which restart the process. This fusion process releases photons, light particles, that take thousands to millions of years to travel from the sun's core to its surface before they are emitted as sunlight. Imagine this. The sunlight we enjoy today was actually created in the sun's core thousands of years ago. The role of neutrinos. Ghostly messengers from the core during nuclear fusion. The sun also produces neutrinos, mysterious subatomic particles that barely interact with matter. Trillions of neutrinos pass through your body every second, yet they leave no trace. Scientists study these elusive particles to gain insights into the sun's internal processes, as neutrinos provide a direct glimpse into nuclear fusion reactions occurring in the sun's core. Extreme conditions in the core. The sun's core is the most hostile environment in our solar system. Here's a breakdown of its extreme conditions. Temperature, 15 million degrees C, 27 million degrees. Density, 150 times the density of water. Pressure, 340 billion times Earth's atmospheric pressure. These extreme conditions ensure that nuclear fusion continues uninterrupted, keeping the sun shining for billions of years. How scientists study the sun's core. Since we can't physically travel to the sun's core, scientists use indirect methods to study it. Some of the most important techniques include helioseismology. Just like Earth experiences seismic waves during earthquakes, the sun experiences vibrations due to internal movements. By studying these waves, scientists can infer details about the sun's interior structure. Neutrino detection. Observatories like Super Kamiokande in Japan and Sudbury Neutrino Observatory in Canada detect neutrinos emitted from the sun's core, confirming the fusion process. Computer simulations. Supercomputers model the sun's internal processes, allowing scientists to predict its future behavior and energy output. The sun's core and the solar cycle. The sun undergoes an 11-year solar cycle, during which its activity, such as sunspots and solar flares, increases and decreases. This cycle is influenced by the sun's magnetic field, which originates in its core. When solar activity peaks, Earth experiences more solar storms, affecting satellites, communication systems, and even power grids. What would happen if the sun's core stopped working? If nuclear fusion were to stop in the sun's core, the consequences would be catastrophic. While it would take thousands of years for the surface to cool, Earth would eventually be plunged into an eternal winter. Without the sun's energy, life as we know it would cease to exist. The future of the sun's core. The sun is currently in the main sequence phase, where it efficiently fuses hydrogen into helium. However, in about 5 billion years, the sun's core will run out of hydrogen, causing it to expand into a red giant. Eventually, it will shed its outer layers, leaving behind a dense white dwarf, marking the end of the sun's life cycle. Conclusion: the sun's core is a true marvel of the universe, a place of extreme heat, pressure, and energy production. Understanding it not only helps us appreciate the source of our sunlight, but also unlocks secrets about the fundamental forces shaping our cosmos. Scientists continue to study the sun's core to learn more about nuclear fusion, stellar evolution, and the potential future of our own solar system. If you enjoyed this deep dive into the sun's core, make sure to like, share, and subscribe for more fascinating science content. What other cosmic mysteries would you like us to explore? Let us know in the comments below. See you in the next video.